Hey guys, how you doing? Let's go to number 77 and 79. These problems take a little bit longer, so I just decided to do it as like a separate video, so there's no rush or anything like that. Hope all is going well. A drug manufacturer forms tables by compressing a granular material that contains the active ingredient and various fillers. The hardness of a sample from each batch of tablets produced is measured to control the compression process. The target value for the hardness is mu equals 11.5. The hardness data for a random sample of 20 tablets from one large batch are, and then they list everything there, is there convincing evidence that the 5% confidence level of the mean hardness of the tablets in this batch differs from the target value. Okay, so this is the mean hardness right here, and this is number 77. Just give me 1 second right here. Okay, all good. All right, so let's do it. So we're going to do a whole 4-step hypothesis test. And in this case, it's for mean. So what that actually is, it's a 1-sample t-test for mu. All right, so we start that out right here. First of all, just to write my notes right here is that it looks like that, first of all, the significance level is 5%. So I'll write that down. We don't know the sample mean because we have to, do that in the calculator right here, or the sample standard deviation. But we can actually go and start the null. So I'm just going to go and write down right here state. This is right here we want to test the null. All right, so right here is 11.5 right here, and they want to know, it says right here 11.5. The mean hardness of the tablets in this batch different from the target value. So right here, so the null is mu equals 11.5. The alternative is that it differs, so that's going to be mu does not equal 11.5. So this is, of course, two-sided. Always define the parameter. So we'll say where mu equals right here. And right, it always says it in the question right here, so it should be right down here. The true mean hardness of the tablets in this batch right here. So mu equals the true mean hardness of tablets in this batch. Okay. One thing that it's a little bit confusing here is they don't actually give units. You should, in the parameter, always mention the units. But in this particular problem, it looks like there is no units right here. It's just like some type of hardness compression level or something. So they don't really have a units. And we're going to say using alpha equals 0.05. Okay. Now we'll go to plan. Okay, and right here, don't forget I should have written down that my n value is, of course, 20. So right here, it is a 1-sample t-test. Sorry, it was a test, right? 1-sample t-test for mu. Okay, now we're going to go to random. And it says right here, random sample of 20 tablets. So random sample of n equals 20 tablets. Okay, and let's go 10%. So n equals 20 is going to be less than 0.10 of right here all tablets in the batch. Okay. Yeah, we're just assuming that, but I think that's fine. And then right here, we're going to go to, remember, for mu, it's normal large sample, right? Okay, here's the problem. N at 20 is not greater than or equal to 30. So, and it does not say that the population distribution is normally distributed. So we have to draw a graph in this case. So let's go ahead and do that. All right, let's go draw our graph. Okay, so I have to put all of these data values right here in the calculator because they're not organized from least to greatest, so I'm going to put them all in, which I already did. Go to stat right here. So they're in, and see that they're already in there. So I'm going to go to stat right here and go to sort ascending and second L1. There we go. Done. Go back to stat, and it should all be in order. So my least is 11.36 and my greatest is 11.71. Okay, so 11.36. So I'm going to say right here 11.3, and the biggest is 11.71. So I'm going to go just to 11.8, and I could just go up by 0.1, should be fine. Let me just move this way a little bit. Okay. Okay, so that should be good enough right there. All right, so we're just going to go and take all of these values, and hang on, I'm just going to erase this right here so it doesn't get in the way. There we go. Okay, so let's take all of these values right here and plot them. But remember, I have it all in the calculator, so easier actually if I just use it right from the calculator. Since it's in order, it'll be a lot faster. Okay, so no problem. There we go. All right, so let me go from the beginning. So you have 11.36, 11.37, 11.38, 36, 37, 38. There we go. 11.42, 9, 11.458. So 429, 458. And let's see. Trying to make this so it doesn't. There we go. That's better. Okay. What do we have next? 11.463, 11.472. 463, 472. All right. Let's go down a little bit. So let's see here. We stopped at 472. So there we go. 477 is about still right here before 5. Then 485 is still about right there. And then we have 493. Ooh, we have a lot right around here. Okay, so everything's there. You know what? As a matter of fact, now that I see this a little bit better, sorry about this, guys. I'm going to change this because we have so many values that are right around 4. I'm going to do it by right here. We'll still start at 11.3, but I'm going to do it as 11.35, right? And then this way we're going to go up. I think if we go up by here, just 11.40, 11.45, there we go. This will be better. If we go up by 0.05, all right, so 40, 45, 11, 11.55, and we're going all the way up to what? The highest was 11.7. Okay, 11.55, 11.60, 11.65, 11.7, and 11.715. So we're going to go, we'll end up right there with 11.75. All right, this will be better. All right, sorry about that little flub up right there. So let's fix that now. We'll go and we'll be easier. 3637 3842, right? So 3637 3842. There we go. We'll take them by in bunches, and now we'll go right here. 4546 47. 454647. There we go. Now that's going to start with we're starting right here at 477 485. 477 485. 493, 5, and then we're going right here to 509, which is just like right there. 531, 552, and 57. What did I do here? All right, there we go. So where were we at? 552, 57. Like right here. All right, sorry about that. I did the tick marks wrong. 0.59. You can just do this right here to kind of just fix it, though. You could just go right here. This is 11.55. Okay, that's fine. All right, and then right here, 0.60 right here is what we have. Going on 613, 623, and 627. Okay, and then what else? 715, and that's it. Okay, so about like that. All right, definitely a pain for sure, but we got it. Okay, so there it is. So we'll just go ahead and say there is no strong skewness or outliers. And we're talking about right here, just to label this as hardness. Okay, all good. Now we're going to go to right here to do. All right, so we have all of these. So this is something we kind of would have to do. At least we'd have to put these in the calculator, even if you're just doing this partly. If you're doing like the whole thing using the tests, you would obviously have to put in a calculator. But even if you're just doing a getting the p-value by getting the t-test statistic, you'll still have to put these values in the calculator any way you do it. So what I do is I have to go to right here. I go to stat, and I'm going to go to tests, and I'm going to go to t-test right there. All right, and we're doing it by data. Okay, the null mean is up here, which is should be in the state right here, which is where up here. Here it is. All right, it should be right there in the state, and it's right in front of me. 11.5 is the null mean. Okay, list is L1 frequency, and it's not equal to, and we calculate it right there. There we go. Okay, so let's go back down here. So we have the t-score is 0.7724. All right, and we also need the p-value and the degrees of freedom. The p-value is 0.4494. And don't forget the degrees of freedom. That's easy. We don't even need the calculator for that. That's just going to be n minus 1. And just to remind you, is 20 right there. So the degrees of freedom is just 19. Okay, if you're going to do this all by the formula, you would, of course, have to use the formula for a t-test statistic right here, which is just going to be the sample mean minus the parameter, which is mu, over the standard error of the mean. So that's just going to be the sample standard deviation over the square root of n. Okay, and then you would just get that, get the p-value for both sides, for a two-sided p-value, and that will give you your answer. All right, if you want to do it that way. All right, now we're going to go to conclude. So we're going to say right here, because the p-value equals 0.4494, which is a rather large p-value. All right, we're going to compare that to 0.05. Obviously, the p-value is high right here. So because the p-value is 0.4494 is greater than alpha equals 0.05, we fail to reject the null. Okay, the p-value is high, we fail to reject H sub O. If the p-value is low, we reject it. All right, and then we're going to say we do not. Have convincing evidence that the true mean hardness of these tablets is different than 11.5. So if it's not equal to, you just say different. Okay, and that's it right there. So that is the whole four-step process right there. We had right here, remember, there's state, there's plan, there's the do, and don't forget right here, I forgot, should put tech right here to show we did on a calculator. All right, and then conclude. If you're really insistent on just doing it the other way of not using the calculator, not using the t-test, you would have had to right here get the t-test statistic right here. So you would have had to go, and to get that, you need to get the sample mean, right? So you would have had to press stat, go to calc, go to one variable stats. There you go. And they give you 11.516 right here as the sample mean. And the null mean is, of course, just going to be, what was it again? It's up here. There we go, 11.5 right up there. Over the sample standard, over the standard error, which is the sample standard deviation divided by the square root of n. All right, the sample standard deviation is again right here. It's 0.09495, right? So if I'm rounding that, it says 0.09496. I'm going to round that to 0.09496, right? Is that what I had? 0.09496, yes. Okay. Or if you just want to actually just do it to 4 decimals, that would actually go up to 0.0950. Should be fine. Over the square root of n, n once again is going to be 20, right? There it is. Okay, so you would put all that in at once right here. And again, in my opinion, it's easier just to do it by the t-test on your calculator, but whatever. All right, so this is good to know how to do this for multiple choice purposes. 11.516 minus 11.5. I always put that part in parentheses, of course, because then you want to tell it subtract first, then divide, right? And then you have, and then another parentheses, 0.0950 divided by the square root of 20. There we go. And we're, oh, sorry. And then we'll go over here. And now we got it. So it's 0.7532. All right, so pretty higher t score right here. So let's see what it looks like when we're drawing our graph. We have 0 right here. This is -1. This is +1. All right. So so what we'll say is it's 0.7532, right? All right. So that what that means is it's two-sided. So -0.7532 and +0.7532 are right here. So these are. It's obviously why we had such a large p-value. Look right here, all this area. Okay, so it's to the left and to the right. So if I'm figuring out the p-value right here, I just go and say second distribution, and I'm going to go to inverse t. Okay, and then you just put in your area, degrees of freedom. So the area is, oh, I'm sorry, it's not inverse t. I'm sorry, guys. So it is second distribution. My fault. It is TCDF. My fault. There we go. All right. So there. Let me fix this. Okay. Let's go to second distribution. TCDF. I'm sorry. If you have the area already, then it's inverse t. So it's this TCDF. Okay. So there we go. Lower -10,000. Upper is -0.7532. The degrees of freedom right here is once again n-1. If you recall, that ended up being 20, so it's 20 minus 1, which is 19. There we go. All right, so that comes out to be 0.230. So, and then I have to multiply that by 2. So let me just put all what I put in. So it's, let me fix that. So it's TCDF, okay, and lower is -10,000. Upper is -0.7532, and then you just put the degrees of freedom, which is 19, okay, is how that's put in right there. And you get 0.230. Now remember, it's two-sided, so it's 0.230. 0.2303 if you round it, and then times 2. So that comes out to what, 0.4606 is my p-value. Okay, a little bit more complicated, especially if it's two-sided. You have to remember to multiply it by 2. Anyway, it should be comparable to what we had gotten by the calculator. The calculator, this is more accurate because it's the whole thing is done by the actual raw data. So this is more accurate, but anyway, ours was, very close to that. All right, so if you ask me, I would recommend actually just doing it this way by just doing the t. This is just by using You just do stat and then go to t-test. All right. Definitely easier, although it is good to what I just showed you, good to know that for multiple choice purposes. Okay, guys, we are good. Have a good day.